Well, welcome everyone. This is day two of GSE UK virtual conference for 2024. And if you're not interested in the DB2 stream, you've come to the wrong place. This is a DB2 stream, and kicking off day two, we have my cohort and co-host and co-chairman of the DB2 stream, Marcus Davidge from BMC Software. And he's probably the only person I know that I'm regularly in contact with that speaks fluent Welsh. So over to you then, Marcus. Please do post any questions in the chat, and I can unmute people as required to discuss the questions as we go. And that's it, really. Enjoy day two. Over to Marcus. And the session is called, which I should have said earlier, session is called Driving Down Business Development Dollars, and it's session 6G. Over to you, Marcus. Good luck.
Thanks very much, Colin. And you'll be happy to hear that I won't be giving this presentation in Welsh. Let's see if this works. Yep, so the title is Driving Down Database Development Dollars, Tips for DBAs and Application Programmers to Help Reduce Costs. The agenda of the presentation, I shall introduce to you the challenge of cost reduction, the characters in my story, the importance of collaboration, and the conclusion. So what's the challenge? How many of you have been through cost-cutting exercises on the mainframe? Excuse me. I've lost count of the number of headcount reductions I've personally narrowly missed from we're outsourcing all of our developers to insert country here, which led to, oh dear, they can't even write COBOL. Oh, too late, our devs have already gone. From where we are going, we don't need no DBAs, and what do DBAs do anyway, to please come back, we need you, we are sorry. Or this software is too expensive, let's replace it. To, oh no, the ISV has stiffed us again. Or let's move this workload off the mainframe to save costs. To, oh dear, the mainframe costs haven't gone down, and now I have to pay additional server and staffing costs. Or the mainframe is too expensive, let's replace it with thousands of servers instead. Whoops, the bank has gone down. Or the mainframe is too expensive, let's chuck our workload up into the cloud. Oh, rats, our cloud provider has hiked their prices up by 29%. So anybody who's ever worked on the mainframe has faced these challenges at one time or another, the challenge of cost savings. So obviously, as you all know, mainframe systems are designed to be used by large numbers of people. Most of those who interact with mainframes are end users, people who use the applications that are hosted on the system. People, bank customers, grocery customers, insurance customers. However, because of the large number of end users and applications running on the system and the sophistication and complexity of the system software that supports the users and applications, a variety of roles are needed to operate and support the system. In the IT field, these roles are referred to by a number of different titles, such as systems programmers, systems administrators, security administrators, database administrators, system operators, production control analysts or schedulers, performance and capacity analysts, application designers, architects, programmers, each have their own role to play, but once established, the mainframe machine workload can increase, the number of end users can increase, but the infrastructure support headcount doesn't have to. And so with some judicious jiggery-pokery and development, the costs can be kept down. So let me introduce you to the characters. We'll start off with the developer. So here's your stereotypical millennial developer. Ponytail, hoodie, geek t-shirt, running VS Code on a Mac, sat in a coffee shop turning coffee into code. He's probably never seen a green screen in his life. I personally started my own mainframe career as a COBOL developer, also writing Syncom's Mantis, 4GL, accessing Syncom's Supra database, moving on to Software AG's Natural, Adabas, and then on to DB2. When I became a DB2 sysprog, writing in assembler and Rex, the hubris, the pride kicked in, and I looked down on dumb developers who were writing inefficient code, bringing my finely tuned, beloved DB2 subsystem into disrepute. After a time consulting, I became a DBA, designing tables, using production callouts. I spent a lot of time writing Rex applications to improve productivity, performance, monitoring, recoveries, reporting. And now I'm a developer again, and I approach my job with a newfound respect and admiration and 20 years of DBA performance tuning. So what are the challenges the developers face? Many of these are ongoing concerns in the mainframe space. Such pressures include the skills gap. A persistent challenge is the shortage of mainframe developers where the necessary skills and expertise are lacking. As experienced mainframe developers retire, finding and training new talent becomes increasingly critical. Security and compliance. Security is always a top concern. And as mainframes store vast amounts of sensitive data, developers need to stay updated on security best practices and compliance requirements, especially with the evolving landscape of data protection regulations. Integration challenges. Mobile apps, web services, they all pose challenges, and developers have to find efficient ways to bridge the gap between legacy and modern systems. Modernization demands. Leverage cloud computing, microservices, modern development practices to enhance agility and cost efficiency. Cost management. Yes, mainframe environments can be costly to maintain, and businesses are looking for ways to reduce operational expenses. So developers are under pressure to optimize their code for performance and resource utilization. The greater need for agility and faster development cycles push mainframe developers to adopt DevOps practices and use automation tools to stream development and development processes. And compatibility with legacy dependencies. Many mainframes have old technologies and languages, and developers need to manage these dependencies while modernizing applications. Software developers, one of the many unsung heroes of the pandemic, working furiously in the background to enable companies to shift to digital overnight, pushing the boundaries of innovation, providing the backbone of digital infrastructure to manage millions of new users online. Since then, being a developer isn't an easy job. They're under constant pressure to deliver more code more quickly, more often, more correctly, with shorter cycles, tighter deadlines, changing requirements, heavier workloads, bug fixing, testing. They're expected to innovate, keep up to date with coding practices and DB2 enhancements, and at the same time, reduce costs. Surveys have been acknowledging the increased pressure for businesses to transform throughout the course of the pandemic, driving a new pace of change that a recent Cisco AppDynamics survey of 1,050 technologists across 11 countries said was pushing businesses to transform into a digital-first operation 3 times faster than they had before the pandemic. And this had created a complex patchwork of legacy and cloud technologies, driving 89% of technologists to feel under immense pressure at work. Here are some more statistics regarding the uptake of IT after the pandemic. So what can we do to help? Well, more than can be included in one presentation. So this is GSE, so that's narrow our focus to reducing costs on the mainframe and what a DB2 developer can do, and later on a DB2 DBA. So let me show you a couple of instances how we can save costs that I've picked up on my journey as a DBA and as a developer. So here we've got 2 similar looking tables of similar data types with similar keys, but containing unrelated data. So a Cartesian join or a Cartesian product is where two or more tables are joined with no predicates, so that for each row in one table, you get every row in the joined table. This is also called a cross join, probably because the DBA will get very cross if he or she catches you doing one. Firstly, and obviously, if you join tables, use a sensible join clause and specify the columns you are joining on. So here we go. This is completely senseless, pointless query. Make sure the predicates are indexed. Make sure the data returned is sensible, consistent, and related. And thirdly, don't select asterisk. Only select the columns and the rows you are interested in. This reduces I/O, CPU, and network traffic. Now, this one was an easy CPU win. I actually saw this. Gosh, no qualifiers, no where clause, no predicates, no really. And this statement was executed per transaction. At the beginning of each transaction, this was squirted out. So no wonder there was a CPU spike and a long delay every transaction. So this is an easy CPU win. Any answers? Well, this will obviously be the first answer. DB2 recognizes the statement as calling an internal function, current date, against system-E1, and so it performs no I/O. In the second answer, DB2 gets the date register from the environment variables without the overhead of doing a select, even though DB2 knows that it doesn't need to actually do any I/O. But why ask DB2 to ask the operating system to get the time when you can do it yourself? So in COBOL, use the current date function. In assembler, use the stored clock instruction. And in Java, use the Ginny wrapper for the Z architecture store clock instruction. There are more than one way to skin a cat. So here's an interesting one. Select current application compatibility. So since version 12, and to some extent version 11, you've been able to run code, run packages at different application compatibility levels. And so if you wanted to find out if your code wanted to find out what current application compatibility level it was using, you can use this call. So it uses system-E1, the optimizer recognizes this and performs no I/O. It uses a special register, so that's in storage. So what's wrong? Nothing. There's nothing wrong with this statement at all. But it's in the middle of a loop and it's executed for each iteration. So this could be in the hundreds of thousands. The application compatibility isn't going to change suddenly during the execution of a package. It's a package level property. So just do it once and outside a loop. Another way to save coding costs. What happens when you miss the first index key in a where clause? You may get you may get a CPU intensive non-matching index scan, or worse, a tablespace scan. So provide as many indexed predicates as you can in your where clause. Next, what happens when you don't miss the first key in a where clause, but its cardinality is 1? So you query, you specify the first key of the where clause, so you think, yes, matching index scan. But if the cardinality is 1, it may start off with a matching index scan, but DB2 realizes that it's scanning all of the index pages because they all qualify, and it might switch to a sequential scan. So speak with your DBA, do some data analysis. You might need to change the order of the key columns in the index in order to reduce the number of results first. So reducing costs in IBM mainframe DB2 application development requires a combination of efficient coding practices, optimization strategies, and collaboration with other teams. I would assert that 90% or more of DB2 performance issues or CPU costs are down to application SQL. So here's some hints and tips to help developers in their endeavor. Optimize your SQL queries first. Use indexes, minimize table space scans, reduce unnecessary joins, reduce data transfer, minimize the amount of data transfer between the application and the DB2 database. Fetch only the columns and rows needed. Don't do select. Index your predicates. Try not to sort if you can help it. And if you have to, can you use the cluster? If you have to sort, can you use the clustering index? Use fetch first or fetch first n rows, fetch first n rows only. That limits the result sets. How about using native SQL store procedures or user-defined functions? This embeds the processing within the DB2 engine, and it's free as it uses zip processors and drastically reduces network traffic. If you're using dynamic SQL, use parameterized queries so that when DB2 prepares the statement in the dynamic statement cache, they can be reused, avoiding recompiling them each time. So this saves CPU cycles and reduces costs. So I'm making that statement again. You reuse prepared statements. So use parameterized queries. So don't have the same query or similar queries with hard-coded values. Use parameter markers. DB2 can reuse that statement. That's crucial. Connection pooling. Use data compression. It reduces storage costs without sacrificing performance. Use efficient data types. For example, don't use integer instead of char for storing numeric values. I've seen that before. This is the worst one. Use date data type instead of integer for storing dates. Think of that for a second. There was this application that stored dates in an integer data type. So you couldn't do data arithmetic on this. Plus or minus 1 days, no, out of the park. Also, if you're using lobs, analyze the lob data to see how much of the lob space is actually occupied by data. And if possible, store them as inline lobs within the base table. This drastically reduces unnecessary I/O, and it makes them eligible for table compression, which is far more efficient than lob compression. I've got another presentation about the differences between table and lob and index compression. If you need to, you can put the table in a bigger buffer pool to accommodate this. Indexing strategy. Create indexes that are based on query patterns. Avoid creating unnecessary indexes that add to the maintenance overhead of and elapsed times for updates and deletes and inserts. And avoid stage 3 predicates. Let DB2 give you exactly the results that you require. I'll be talking about predicates later on, and stage 1, stage 2, and stage 3. But let DB2 itself do the filtering by providing as many predicates as possible. Work closely with your DBAs to understand database configurations, tuning options, best practices, buffer pool placement. Do you have reference tables that are accessed so frequently that locking them in memory would be a good option? Maybe reordering index keys or adding include columns to make the index access faster, or change the clustering index to reduce sorts. Most importantly, invite your DBAs to agile scrums. Resource constraints. Be aware of memory, I/O, CPU constraints. Try and use lock avoidance when possible. Use with UR if it's appropriate, and try to avoid sort as much as possible. Stay informed. Attend conferences, sessions, webinars, stuff like this. Pick up on the best practices that's out there. If you use VS Code, there are plenty of DB2. Well, there are 2 really good DB2 extensions out there. Other companies of BMC and Broadcom, they've developed their own DB2 extensions. These are there to help you build, validate, format, and test your SQL statements before you run them in your development environment. But most of all, the most important tip I can give you as a developer is to use Explain. Use the DB2 Explain feature to analyze your query execution plans, identify areas for optimization. Performance tools with Visual Explain features help you gain a better understanding of how your query is performing. So let's have a look at optimizing SQL queries. Here's a drastically simplified diagram of the internal processing of an SQL search argument. Search argument led to the word search argumentable, which then led to sargable or sargeable. So here we go. Your users here, they fling their SQL at DB2 using Spoofy or program packages or whatever. If it's dynamic, the statement is prepared. If it's static, the package has already been bound. Either way, the access path has been optimized as best the DB2 optimizer can manage, given the information in the SQL statement itself and in the statistics of the tables that the statement is querying. So the optimizer comes along, looks at the SQL statement, determines which of the predicates in the where statement can be satisfied using index access. So a stage 1, here we go, a stage 1 predicate is evaluated by the data manager, and that's evaluated first. Data manager in the DBM1 address space. The results of this are then passed to the relational data server in the master address space, and this applies the stage 2 predicates. The more data passed between the data manager and RDS, the more overhead. Obviously, therefore, the less data passed, the less the overhead. So try and make your predicates stage 1 if possible. Here's a little tip. All indexable predicates are stage 1, but not all stage 1 predicates are indexable. So, for example, player 1 provides only one of 2 key columns, where key col equals 1. The search argument is indexable and stage 1, meaning the data manager scans the index for key col 1 entries matching 1. There are 2 of them, this one and this one. It fetches the data, passes it back to RDS, and because the user is asking for all columns with key col 1 equals 1, it passes them all back to the user. Fine. Player 2 provides both key columns. The search argument is indexable and stage 1. Both columns are provided. This is a unique match. Only one row is returned to RDS, and only one row is returned to the user. Player 3 provides one key column and one data column. So key col 1 equals 1, data col 1 equals cake. The data manager retrieves 2 rows for key col 1, passes them onto RDS. RDS applies this filter to the stage 2 non-indexable predicates, where data col 1 equals cake, and then passes this one remaining row to the user. Player 4 doesn't provide any keys. There are no stage 1 solvable arguments. The data manager has to do a table scan, passes all rows to RDS. RDS then applies the stage 2 predicate where data col1 equals cake, and then filters out the 2 qualifying rows, this one and this one. Oops. Right. These are then sorted, ordered by data col3, which uses the DSN DB01 sortwork database, passes it back to RDS, and then RDS passes the 2 qualifying rows back to the user. So the optimizer is pretty good at rewriting queries to be more efficient. In fact, it's probably better at it than you. However, there are many things you can do to improve your SQL performance. For example, don't use scalar functions on columns in your search predicates. So this query is stage 2 because a function is specified. DB2 queries each row and applies the year function to hire date to get the desired result set. Instead, use a stage 1 predicate. So you're actually giving the hire date range to the data manager. The data manager passes the qualifying rows back to RDS. Another example. Talking of betweens, what's the difference between between and between? Or rather, what's the difference between greater than or equal to and less than or equal to? So yes, this is a valid SQL statement, but this is stage 2. So DB2 has to pass all of the data from the data manager to RDS. RDS then queries each row and applies the predicate is column 1 between host variable 1 and host variable 2. This is an awfully performing statement. Here, where host variable between column 1 and column 2, that's even worse. So instead, do this, where host variable is greater or equal to column 1 and host variable is less than or equal to column 2. So in your DIY query rewrite, code the most restrictive predicates first. I, in my years as a DBA, had to support a product, an off-the-shelf product. Most of the tables, there were 800 and something tables. Most of them had the first 3 columns of key columns of each index on each of the tables were company, product, and policy. So company had a cardinality of 1 always. The product had a cardinality, it was about between 10 and 20, and that was a 3-byte character. The policy, so company product policy, the policy column was an integer between 1 and 999,999,999. So if you do an index access, you might want to rearrange the physical index implementation to put policy first, so thus reducing the number of rows returned in the first place. So yeah, cast in order of experience, in order of appearance. Sorry. Next slide. Reduce data transfer. IBM are actually adding more stage 1 predicates with each version of DB2. So keep up to date with DB2 releases. Fetch only the columns and rows needed. I keep hammering on this one. Don't do select asterisks. Index your predicates, try and use stage 1 as much as possible, and always put an index on your join columns. Sorts, if you can, sort by the clustering index instead of order by. Join on clustered columns. This is an important one. I've seen this before, where you're joining two tables together and the columns that you're joining on aren't clustered. And try and avoid sort if you can. Reduce data transfer by using fetches, optimizing, or native store procedures. Use a pragmatic index strategy. So I call this +1, oops, -1. Keep adding indexes to improve performance. So you've got a table, you've got a primary key, primary index, but if you start accessing the table using predicates that aren't in the primary key, then you add an index on those key columns, on those columns, to improve your select. Fine. So another select comes along with different predicates. So you add a column onto that to improve, that performance. So that's a pretty good pragmatic approach to building indexes. But when your DML performance starts to degrade, your insert, update, and delete, that's when you need to stop adding indexes. And you might need to actually drop the last index that you created if you're actually impacting performance to a tangible level. So Visual Studio Code, I've mentioned this earlier. It's a free source code editor made by Microsoft for Windows, Linux, Mac OS, and now Raspberry Pi, if you like coding on that. It's got intelligent code completion, syntax highlighting, code snippets, code refactoring, embedded Git, and now, depending on how much you want to pay, embedded AI. IBM Z Open Editor is an extension that provides language support for COBOL, PL1, high-level assembler, JCL, Rex. So here's some COBOL, here's assembler, the DB2 developer extension looks a little bit like this. You can browse objects, get metadata about them. You can issue SQL statements. You can browse the results and save them in CSV files by clicking on this little blue icon there.
Just a quick statement,
Yep.
Marcus. Dion's just mentioned if the result set is going to be the same, maybe it's an idea for the optimizer to include this in a query rewrite case.
Ooh,
should the optimizer be cleverer for some of these queries? It's a good point for IBM, but I don't think.
Yeah, it's a good point. If the result set is going to be the same, maybe it's an idea for the optimizer to include this in the query rewrite use case. Well, that's what IBM have brought up the AHA platform for.
Yeah.
Good
so
question.
If anybody thinks that's a good idea, please go and support that.
Yeah.
Yeah. AHA. And Dion, nice I guess you'll raise the AHA.
Go for it. Here's a DB2 Connect extension. What's cool about this is what I like. I can't remember the syntax for create procedure or merge. So, excuse me. The code snippets are really useful, so it builds the syntax for you. I've actually forgotten how many tables are in the DB2 explain function now. It used to be 23, but I think it may have gone up. But there you go. When you bind a plan or package or statement, or you can use the explain statement in Spoofy. These tables, most of these tables are populated with information about the access paths. The DB2 optimizer uses these to choose its best access path. This is sheer gold for performance analysts. Vendors have built tools around this set of tables and their functions. And there have been many good presentations, papers, and books explaining the explain function. So we're still on developers. We haven't moved to DBAs yet. So let's leave SQL and move on to other ways of reducing costs. I've seen application performance improve merely by updating the level of your compiler. DB2 performance has itself improved merely by IBM recompiling everything with their latest version of the PLX compiler. That was in DB2 version 8. There was a CPU plummeted by about 20%. Compiler tips. So if you code, don't know how many of the audience actually codes in COBOL, but this is quite important. The ARC or Arch option references the machine architecture, so short for architecture, for which the executable program instructions are to be generated. If you specify a higher Arch level, the compiler generates code that uses newer and faster instructions. But your application might bend if it runs on a processor with an architecture level that's lower than what you specified with the Arch option. So use the Arch level that matches the lowest machine architecture where your application runs. So if you don't specify the Arch option on your compiler, the default is Arch 7 for COBOL 6.2, Arch 8 for COBOL 6.3, and 10 for COBOL 6.4. So if you're running COBOL 6.4, the default is Arch 10, which is ZEC 12. If you're running anything higher than a Z12, an EC12, if you're running a Z13, 14, 15, or 16, the default on COBOL 6.4 is Arch 10. So you're missing out on newer and faster instructions. So if you've got Z16s everywhere, use Arch 14. If you've got Z16s everywhere bar one machine, and suddenly you have to DR switch to that machine, then you must make sure that you are not running anything higher than ZArch 13. So always run the architecture option at the highest that you possibly can, depending on the lowest machine architecture that you've got. Just check out what you've got and don't use the default because you're missing out. Compiler tips. If you're writing your applications in Rex, compile it. I've seen drastic reduction in CPU time merely by compiling your Rex. If you're doing a lot of development, why not compile off the mainframe? So you can actually buy vendor solutions that compiles your COBOL, C, C++, or assembler into ZOS compliant object code. You can then FTP that object code to the mainframe, do the link and bind on the mainframe. So you're not actually using your mainframe GPU or not GPU, general CPU. You're not using your mainframe general CPUs to do your compiles. You're using your laptop. So that would save an awful lot of development costs if you're doing a lot of development. Might be worth investigating. More coding tips. Horses for courses. Is the programming language you are using appropriate for the application you are writing. Now, I know some companies that write all of their DB2 utilities in COBOL, which is absolutely fine because it works. Don't knock it. But you don't really need to write your application code for big policy, insurance policy programming in assembler. It's not necessarily the best way to do it. Read books on clean code. Don't repeat your code. Try and reuse it if possible. Use sensible comment. Keep your classes small. Use the distinctive of the language and don't use unnatural acts with them. Gosh, not all instructions are created equal. The compute instruction in COBOL consumes a lot more CPU than add or subtract. Try and use all, code sensibly. Use online resources. I once asked ChatGPT to implement a for loop in ARM assembly, and it was absolutely fine. So I asked it to write a for loop in high-level assembler for the mainframe, and it came up with some small, neat code using registers rather than variables, which made it fast and efficient. More coding tips. Yeah, I mentioned Visual Studio Code. It's got language extensions. Use performance tools. For example, I work for BMC. We've got Strobe, Aptune, DevOps, DB2, and SQL Assurance runs explain against your code's SQL and compares results with your site standards. SonarQube uses code smells, and that's also rules-based. But I think the rules are written in Java, so you have to write your rules in Java and then compile that, or whatever it is that Java does. I'm not a Java coder. Other vendors have their own products as well. You can use automated testing tools to really make your life easier, and maybe actually code in Java. Well, yeah, why Java and not COBOL? So Java compiles to bytecode. Bytecode always uses the latest, the highest Arch compiler option for your CPU. Java can be run on zips, reducing software costs because zips are free. Yeah, yes, you have to buy the zip, but the workload on it are free. But be careful, the zip capacity might overrun and then run the workload on a general processor. So that would become more expensive. Java may actually run faster than COBOL on sub-capacity mainframes because zips always run at full speed. General purpose CPUs don't necessarily always run at full speed. Most mainframe performance monitors from your software vendor that now supports Java. And on the Z14, Java's performance and garbage collection have improved greatly. Interlanguage calls, Java calling COBOL, are not recommended. While this is better with ZOS 2.5, sorry, I said Z instead of Z. Even with automatic 64-bit to 31-bit A mode conversions, the CPU overhead might be costly. And there's a little website there where Andrew Rowley does a coding drag race on the Z, and the results are quite surprising between Java and C. So have a look. Finally, no, not finally, next. When I became a DB2 sysprog, I wrote in assembler and Rex, and I looked on dumb developers who were messing up my DB2 systems. But now I'm a developer again, as I said before. I've come back with a respect and admiration for developers. So the challenges of a DB2 DBA: data growth, I'll skip through these, security and compliance, cost management, integration with new technologies, vendor support and updates, data privacy and ethics, performance optimization, disaster recovery and high availability, complexity of database environments. Can you actually achieve a single point of consistency across multiple DB2s, multiple LPARs, multiple other database management systems on different platforms if you wanted to recover an enterprise to a single point of consistency? Things again really complicated. Automation and DevOps, this improves efficiency and agility. DBAs now are adopting DevOps practices with their database changes. Skills shortages. Yeah, organizations are often struggling to find and retain qualified DB2 professionals. Migration off or on the mainframe. So here's some cost-saving tips. Optimize query performance. Use the tools that the vendors have got, that your company has bought. They're there to help you optimize SQL queries and query plans to reduce CPU and I/O optimization. Follow best practice. Use data compression where necessary. As I said earlier, use inline lobs when you can. Tune your buffer pools pragmatically. Adjust the settings to optimize memory usage and reduce I/O. Developers need to talk to DBAs. DBAs need to talk to sysprogs. So DBAs here, the linchpin between developers and operations. So a couple of tips: keep the catalog and only the catalog in BP0. If you want to lock frequently accessed tables in their own buffer pools, speak to the developers, speak to the sysprogs. Make sure your memory allocation is appropriate for the size of the tables. Always segregate table spaces from indexes. Do you want to segregate random I/O to sequential I/O? Sometimes you can get better performance by moving data pages from 4K to 8K. It reduces I/O operations, especially with inline lobs. Use your ISV tools for monitoring, alerting, workload management, automation and scripting. Your vendors can help with this. Housekeeping for performance. Oh boy. Yes, I've seen, oh gosh, automated reorgs save £500,000. Yeah, £450,000 off the CPU bill merely by implementing automated reorgs. This reduces human error, saves time, and if you try and shift left your database changes to developers using DevOps or orchestration tools, and you've embedded DDL validation and DML validation so that your SQL doesn't perform badly, also so that you're not breaking naming standards or object placement rules. All of that can be automated. So the DBAs can control the rules, but the developers, they can get the job done themselves, moving their database changes along with their code changes all the way through the life cycle up to, but not including production, which is when the DBA comes in and has the final say. I've actually seen a £3 million reduction in CPU cost merely by applying rules to development SQL standards. I've talked about pragmatic index management. As soon as you get to a certain point, they consume more CPU on synchronous updates than they do save CPU on select statements. I've actually seen tables with 13 indexes on as a rule of thumb. 13, that's just ridiculous. My rule of thumb is 3 to 4, but your mileage may vary. I've heard even worse horror stories, but I can't remember the numbers involved. I mean, why would you need more than 13 indexes on a table? Archiving and purging. This is becoming less of an issue. Now you've got cloud database and you can actually, with certain vendor tools, put unit equals cloud instead of unit equals 3380 or whatever. Capacity planning, yeah, speak to your ops people. Optimize backup and recovery. Yeah, once again, use your vendor tools. Keep your recovery JCL at the ready. Know where it is and what it does. Regularly test and refine your disaster recovery procedures, and work out each application's SLA. They will vary. Like your management information wouldn't have the same SLA, recovery SLA, as your online transaction database. And educate and train. As a DBA, I liked mentoring junior DBAs. And when I was a developer, and still am, now I'm a developer again, I liked being taught how to do stuff, what the local best practices and development practices are by senior members. So try and engage some sort of mentorship. I heard yesterday a mentorship conga, where you're mentored by someone, but you also mentor somebody else. And I keep up to date with conferences, vendors, IBM, Interskill, LinkedIn. Rushing towards the end. Oh, I've got 8 minutes. Ops. So ops face the same challenges that developers and DBAs face. Skilled workforce coming up over and over again. Performance, high availability, automation. So what can we do to help operations? So consolidation, I've heard of hundreds of Linux servers, workloads being consolidated on a single Linux One mainframe. Even 100 Microsoft Exchange servers being converted to open source mail SMTP and run on a single IFL on an already running Linux, already running Z mainframe. Automation, so automating backups, data transfers, maybe even DevOpsify your maintenance schedule. Other things that operations can use to improve CPU and improve cost reduction. Oh, collaboration, yes. I keep going on about collaboration. DevOps is about people's processes and procedures. Talk. DBAs are generally the linchpin between developers and ops. So DevOps, automation, and collaboration have appeared in each stage of this presentation because I find it quite important. DevOps provides developers with a well-defined automated process or pipeline to deploy code from one system to another. But here's your developer. He's happily coding away, making changes to applications according to business requirements. He needs a new column added to a table. So he flings the request to the DBA, who makes the change, and he makes another change from another developer. He deploys the code to prod. Prod sends an operational change request back to the DBA, maybe a new index because of a badly performing query, or a prod reorg request. So you can see why the DBA is a bottleneck. So here's an Agile developer delivering database changes to a DBA. And here's a DBA being invited to an Agile Scrum. Sorry, not really. This is a joke. DBAs are never invited to Agile Scrums. And that's the problem. So the world I'm suggesting is that database changes are impact assessed, schema changes are encapsulated in a change orchestration process like Jenkins or Urban Code Deploy. The DDL is validated against site standards that the DBAs have set. The code's SQL statements is analyzed compared against performance rules defined by the DBA based on explained access paths. The developer then can migrate his own SQL changes as well as his code changes all the way through to acceptance test without the database administrator getting involved. So the DBA comes along and validates the final change into prod. So at each step, the developer is in charge of his own development. So automated routines like this prevent bad SQL from reaching production, prevents badly defined objects from hitting production. This is where collaboration brings a sweet spot. So my conclusion, everybody's seen this. The last mainframe was not unplugged on March the 15th, 1996. The best explanation of the business value of the mainframe that I've seen is a mainframe executive documenting for her management the business benefit they received from the mainframe. And this is what she said. 20 billion monthly DB2 transactions, 10 million batch jobs, 7 nines uptimes. 7 nines, 99.999999%. Oh, that's 8. Actually equates to 3 unplanned seconds per average calendar year. The mainframe, this company's mainframe runs 80 million lines of production code, 1,200 production changes monthly, 40 million utility jobs annually, 100% of tier 1 applications in 4 hours, and a recovery of a DB2 table in 4 hours or less. So the BMC mainframe survey of 2021 said that 92% of respondents see the mainframe as a long-term platform for growth. 72% have more than 50% of their data on the mainframe. That figure is just going up in the BMC 2023 mainframe survey. So the future of the mainframe is looking better than ever. But to reduce database development costs, you have to collaborate. Yes, I've given SQL tips, I've given compiler tips, I've given coding tips, but in order to seriously develop cheaper, then collaborate, talk. That's what it's all about. Thank you very much, everyone. I hope this has been useful. The session is 6G, so scan, click on the agenda. Let me know whether you thought this was good or not, because that way Colin and I can improve the profile of speaker content for the next conference.
Okay, thanks very much, Marcus. There'll be a rousing round of applause normally, but obviously we're virtual, so there won't be. If anybody has got any questions, please do put it in the chat now. and we take them quickly before we close. There's nothing in there at the moment. Oh, there's a round of applause for you from George. Thank you, George.
Thanks, George.
That works. Okay, there's nothing appearing in the chat at the moment, I don't think. Darren's going to email you afterwards, so that's okay. There's email address, I think, in the bio. Right. I think it's 10 o'clock, so that's coffee time. Thanks very much, Marcus. Brilliant. Lots of things in there that I'll take away as well. So it's good. Good stuff. Thank you.
Thank you. And I'll see you all later.
Yeah, the next session is 10:30 with Emil Kottridge for DB2, and it's DB2 13 application development topics after the coffee break. That's at 10:30. So please do fill in the feedback and catch you later.
Cheerio.
Thanks, everyone.